Section 3.5 in the grade 9 applied course, looking at interior and exterior angles in a polygon. So we want to find any angle in any shape. That's what we're looking for today. And here's a little table that'll give you a guide. This table shows, 4 different shapes. And of course, a polygon could be any number of sides. It doesn't have to be those, but you remember the number of sides in a triangle, quadrilateral, etc. Now this thing of number of triangles, what this means is, if I could cut it in half or cut it apart so that I can make more triangles to help me figure out, because what I'm looking for is the sum of the angles, okay? So if we can cut these triangles in half or in pieces, I know that inside a triangle it's 180, right? So this is 180 in the middle. Well, in a quadrilateral, I can make 2 triangles out of it, right? So since I can make 2 triangles out of it, that must mean that I can make it's 360 degrees. And this pentagon, I can make it into 3 triangles. That means its inside must be 3 times 180. So it's 3 triangles, 1, 2, 3. So the angle sum must be 3 times 180, and etc., etc. So that's the basic idea, finding any angle. But there's actually a nice, easy equation I can give you. And here it is. If I say S is the sum of the interior angles, where for a triangle S would be 3, or sorry, S would be 180, and N is the number of sides in that type of polygon, I can find then the sum of the interior angles. So just to give you what I mean, in the table above, it said that a pentagon is 540. We're going to use the equation and I'll show you why. In a pentagon, you have 5 sides, so that's why N is 5 for 5 sides. And we want to find S. So you use this equation and you end up with 540. 5 minus 2 is 3. 3 times 180 is 540. Okay, so I'm showing there that in a pentagon, the sum of the angles, not each angle, just the sum of the angles is 540. Okay, just to be clear, polygons can have many shapes. You can have many different shapes for a pentagon. In this case, though, when we talk about regular polygons, we're talking about a polygon where every side length is the same and every internal angle is the same. Okay, so every angle here is going to be the same throughout. So if it was a triangle I was looking at, we'd be looking at an equilateral triangle where you have equal side lengths and every angle is 60 degrees. And we know it's 60 because the internal is 180. You divide it by 3 to get 60 for each. Okay, exact same idea for a pentagon, for example. If I want to find what each of these angles is, in the last question we figured that it was 540 was the total. So to find for each, then you just divide 540, which is the sum of all these, by 5. Oopsie, sorry. Okay, so every single one of these angles is 105 degrees. That's 105, that's 105. If you added all those up, you get the 540. So again, to find each angle, you divide sum by n. S by n. Okay, so that's how you do it. You have several assignment questions to work on next. This is it for the videos. You just go ahead and keep working on your assignment questions related to, hopefully you're at the point now, the very next section will be ones related to this and related to using this equation here. Okay, so good luck with that.